this is going to be going over sympathetic and parasympathetic actions. So it's real important to understand what the parasympathetic and the sympathetic nervous systems are going to do. And if you understand how they work, you can understand what effects drugs will have on them. So when we're talking about the sympathetic nervous system, this is often called the fight or flight. So this is the fight or flight system, and this gets us prepared to either run away or fight for our lives. You know, if a bear runs in, what are you going to do? Are you going to freeze? Are you going to, heart rate's probably going to go through the roof, blood pressure's going to skyrocket, your vision's going to get a little sharper. Everything's going to happen in order to try to allow you to run away or to fight. Probably with the bear, you might want to run away. Just a suggestion, but do you. The sympathetic nervous system is going to directly stimulate some of your vital organs, and it's going to make things happen. Now, you also have stimulation of the adrenal medulla, and this is going to release your major neurotransmitters for your sympathetic nervous system, which are epinephrine and norepinephrine, and these are going to be released into the bloodstream. So the sympathetic nervous system comes from the thoracic and lumbar regions of the spinal cord, and you've got these preganglionic nerves. They're going to leave the spinal cord through the spinal nerves and end in the sympathetic ganglia. There are two major types of sympathetic ganglia. You've got your sympathetic chain ganglia, and you've got your collateral ganglia. In addition to this, you've also got those special preganglionic sympathetic nerve fibers that are going to nervate that adrenal medulla that release your epinephrine and norepinephrine. So when you have stimulation of these, the chain ganglia, when you have the sympathetic chain ganglia nerves, these are going to go to the peripheral target tissues of the sympathetic nervous system, and they're going to have a couple of different effects. They are going to increase your heart rate and the force of contraction of the heart muscle. They're going to increase your sweat gland stimulation. They're going to increase the constriction of the blood vessels in the skin. So this is going to cause that shunting that we see sometimes, getting away from the skin and more to the large vessels and organs that are needed to survive. They're going to increase the blood flow to the muscle, that whole fight or flight, right? They're just going to cause bronchodilation, getting you a little more oxygen so that you can provide the fuel for that fight or for that flight. And it's going to increase the glucose breakdown in the liver. Once again, more fuel for running away or fighting for your life. Now, when you have those collateral ganglia that are innervated and stimulated, these are going to do a lot of the things in the abdominal area. So this is going to cause a reduction of the blood flow to the abdominal organs, and the body's, I guess, way of thinking is, you know, that meal that you just ate, if you're about to die, you probably don't need to waste any time or effort digesting it. Let's put it towards the surviving, and then we can come back to the whole digesting of the food. So decreased digestive activity. We're going to have relaxation of smooth muscle in the urinary bladder. And guess what that means? You ever seen somebody pee their pants or had somebody pee their pants? Maybe the dog. It even happens to dogs. Dogs get so excited or so scared they just, whoop, there it goes. That happens to people too. And you have a release of glucose stores in the liver. Now, when we are talking about medications acting on the sympathetic nervous system, if they stimulate the sympathetic nervous system, they are considered to be sympathomimetics. Mimic. I always think of mimicking, like a mimic, something makes it happen. So sympathomimetic is going to stimulate the nervous system. It's going to act like a neurotransmitter for the nervous system. A medication that inhibits the sympathetic nervous system is going to be a sympatholytic. Remember that lytic means to stop something. A lot of our EMS medications are going to stimulate an alpha and a beta receptor site. And remember what the alpha sites do and the beta sites do. If you don't, then there is a little video here that you can watch on that. If a medication is specific to one receptor or another, it is known to be a selective medication or a specific medication, which can be beneficial sometimes. Now, when we talk about the parasympathetic nervous system, this is the rest and digest, and there are a few other probably less socially acceptable ways to put that as well, but we'll go with rest and digest for now. And this comes from the exiting of the nerves at the base of the cranial vault and ends up near the target tissues. All right, so, you know, when they leave the brain, they travel within the 4 cranial nerves. Is the oculomotor, or number 3, the number 7, the facial nerve, number 9, the glossopharyngeal nerve, and number 10, the vagus nerve. These leave the brainstem, and they're a lot longer than the fibers of the sympathetic nervous system because they are actually, the ganglia for the parasympathetic are located near the target tissues as opposed to near the spinal cord itself. So these postsynaptic fibers that are going to nervate the body, this is going to be like the eye muscles, the salivary glands, the heart, the lungs, most of the organs in the abdominal cavity. The sacral segment is actually going to have your distinct pelvic nerves, and these are going to nervate the ganglia in your kidneys, your bladder, your sex organs, and the terminal portions of the large intestines. Now, our primary neurotransmitter of the parasympathetic nervous system is going to be acetylcholine, and acetylcholine is going to act on your muscarinic and your nicotinic receptor sites within the body. And the muscarinic receptor sites are primary receptors that we are dealing with, that we see in your emergency medication. So your stimulation here is going to cause a decrease in heart rate and force of contraction. Sometimes that's good, sometimes that's bad. It's going to cause pupillary constriction. We're going to see an increased digestive gland secretion, so you may see increased saliva production, which can pose an airway problem potentially. We're going to see increased smooth muscle contractions in the GI tract, so increased motility. And then we're going to see bronchoconstriction, which can also cause problems because we're making our airways smaller. If we have medications that are acting on the peripheral nervous system, if they stimulate the parasympathetic nervous system, they are known as parasympathomimetics, much in the same sense of the sympathomimetics. These are parasympathomimetics. And if they inhibit the parasympathetic nervous system, they are known as parasympatholytics. So they are stopping the parasympathetic nervous system.